In this video, we will discuss the different types of element constraints alignments can have. In Civil 3D, there are three types of horizontal alignment elements: fixed, floating, and free. Certain constraints will automatically be placed on the horizontal elements based on the type of element and tool used to create them. A fixed element has a fixed position at both ends. Now, fixed elements are not necessarily tangent. Grip Edit will lose tangency to adjacent alignment elements. For example, if I go ahead and select this alignment here, and we grip move it, you'll notice the tangency is not maintained. That is because this arc is a fixed arc at both ends. Floating elements are tangent to another horizontal element either before it or after it. So if we select this alignment here, notice that when I move this horizontal tangent here, it's automatically adjusting the curve because this curve is a floating curve off of the previously defined tangent. So it reacts in that way because it's a floating curve. Then you have free elements, and what free elements are is they can be attached between either two lines or two curves, and they have the ability to be manipulated from either one. A good example of this is this alignment here. This curve is a free curve. If you modify the tangent, you'll notice here that tangency is maintained and the curve is free to move as you make edits to the other connecting alignment objects. In this video, we will discuss creating alignments using the PI method. If you'd like to follow along with this video, please open the file creatingalignments-pimethod.twg located in the training folder as discussed in the Working with this Dataset video. One of the simplest methods to creating alignment is using PIs, points of intersections. Let's discuss how to do this. First, let's navigate to the Home tab, Create Design panel, Alignment drop-down, Alignment Creation Tools. We'll give our alignment a name of Bypass-1, make sure the type is set to Centerline, give it the style of Layout, and make sure we have our labels set to All Labels. If this alignment required design criteria, we would toggle it on here and have a starting design speed of some sort. Design criteria is how you can apply AASHTO methods to your roadway, as well as the design check sets, such as checking for tangent lengths and curve checks. For now, we'll toggle this off and go ahead and click OK. This opens up the alignment layout tools. We're going to be working with this section of the alignment layout tools as we'll be working with the PI method. Let's click on the drop down here and notice how we can go to the curve and spiral settings to define a default curve for our curves. For now, we'll leave it set to 200 and we'll discuss how to change the curves afterwards. Click OK. And let's go ahead and start by clicking on the Tangent with Curves tool. Since this alignment will start with some known coordinates and some known bearing and distances, we're going to use the transparent commands. Let's first access the northing easting one by typing in '(NE) for northing easting. At the prompt, let's go ahead and type in the northing, which is 901285.932, and then press enter. For the easting, 1456414.0065, and then press enter. This starts out that alignment at that northing easting. Press escape to end the transparent command and notice how we're rubber banding, continuing on the alignment. Some circles have been provided for you to define the additional PIs. Let's go ahead and just snap to them using center snap. Notice how the default radius is being applied to this. Now for this next point, we actually want to tie into a known northing easting for the existing roadway centerline. So we'll type again, '(NE) and then press enter. And now let's type in the northing of 902.046.977.624, press enter. And for the easting, we want 145.4647.92311.6, and then press enter. We're now at that point. Press escape once to get back into the command. And now what we have is, we have a known bearing and distance for the end of the alignment, which matches our existing centerline. So now we'll type in '(BD), press enter. We are now prompted for the quadrant. You can type in 4, which is the northwest quadrant, or just simply click and there's your quadrant. Now for the bearing, notice how you can use spaces, but we'll just type this in using decimal degrees. So we'll type in 66.4514, press enter. That locks in that bearing. And now for a distance, we want 953.01, press enter. Press escape to end the transparent command, press escape again. And there's our alignment with the stationing applied. Now let's go ahead and edit the curves. So by default, it gave those 200-foot radius curves. What we'll do is use the alignment grid view right here, which appears in the panorama window. And note that as you click on the different alignment elements, They will highlight in the file, making it easier for you to see what you're actually editing. We'll go ahead and change our radius here to 850 for the first one and press enter. Zoom out here a little bit, and we'll go ahead and click on this one here. 500 for this one, press enter. Click on this one here. This one also will be 500, press enter. And then for the last curve here, this should be a value of 700 feet and press enter. Don't forget, if you also need to make any edits, you can use the grip editing, and depending on how we created this, of course in this case, this was with the PI method, we will get specific grips to allow it to stretch those different horizontal elements based upon the constraints that were used to create them. In this case, these are free curves because we use the PI method. There are many ways to constrain an alignment, and Civil 3D provides tools to enable you to add horizontal elements to your alignment to aid in this creation. Let's first create an alignment from objects. So we have a line that we want to begin with, the existing center line. So we'll click the alignment drop-down, create alignment from objects. At the prompt, we'll go ahead and select the line and press enter. Notice how you have the ability to reverse it if you need to. In this case, if your arrow goes this way, definitely reverse it, as we need it to go this way for everything to work properly. Click reverse, and now the alignment is going the correct way. We'll name the alignment bypass-1. Make sure it's set to the type of centerline. Set the alignment style to layout, and we'll go ahead and use the all label set. You can toggle off the add curve between tangents, as we don't have any additional segments that we are creating this alignment from. We don't need to add any curves to the alignment yet. Toggle on erase existing entities, that way the align is gone, but notice how you have the option to turn it off if you want to. Make sure design criteria is turned off, and go ahead and click OK. And now we have our first tangent. To get to the alignment layout tools, go ahead and select the alignment and choose Geometry Editor. So we're going to be dealing with these two drop downs here for the fixed, floating, and free linear and fixed, floating, and free curves. The first thing you want to do is we have two circles to define our second tangent. We'll just go ahead and draw this. We'll click on Fixed Line, snap to the center here, and press enter, and there we have our fixed tangent. Because it's not connected, it can't station it yet because of course it doesn't know what our alignment continuation is supposed to be. We'll go ahead and add in a free curve. In the curve dropdown, click on Free Curve Fillet between two entities radius. Again, when you don't know what to do, look to the command line window. We'll go ahead and select the first entity, and then the second entity, and it is less than 180, press enter, and our radius here is 850, and press enter. Now press enter again, and you'll notice the alignment starts to continue with the stationing. Now let's say we want to do a floating curve off of this. So right now we are actually at the PC, not the PI. And let's say you know the length of the curve and you know the radius is supposed to be, you have plenty of tools to do that. Let's click on the curve dropdown, more floating curves, from entity end, radius, and length. So we'll go ahead and pick our end first. Which way does it go? It goes clockwise. And then what's our radius, or as you can see here, you can do degree of curvature. In this case, the radius is supposed to be 500. We'll press 500, enter. And then what's our curve length? It should be 167.78, and then press enter. And there is our floating curve off of that. Now what we want to do is do a floating line off of this curve here. We're at the PT here. So we'll click on floating line from curve end and length. Select your arc to attach to, and now we want to define the length. Now, if I knew the length, I could just type it in. However, you can also snap to the end, and a circle is provided for you to snap to if you need to define it based upon some existing geometry. Press enter, and there's our stationing continuing to update here. Now let's say we have this line here. This is the existing center line that we want to tie into. We'll go ahead and do this in the middle of the command, which is pretty cool. You can just convert AutoCAD lines and arcs to alignment objects. We'll pick the line, and now it's part of the alignment. However, it's not yet stationing because, of course, we don't have it continuing. Now, what we want to do here, let's say, is do a curve and then a reverse curve. So how do we do that? Let's first do a floating curve off of this. We'll go to the curve dropdown and do floating curves from entity end, radius, and length. We'll go ahead and pick our entity end right here. It should go clockwise as well. And for the radius, this should have a radius of 500 as well. And for a distance, we want to type in 180 and press enter. And there is our curve. So to get a reverse curve from this point here, navigate to the curve dropdown, free curve fillet between two entities radius. We'll go ahead and select our curve object first, and then our tangent object here. Is it less than 180? It is. Press enter. Notice how Civil 3D is aware that you picked a curve. It's asking you, do you want a compound curve, a PCC, or a PRC? We want a reverse curve. What's our radius? It should be 700. Press enter, Press enter again, and as you can see, fantastic. It put the PRC in there, stationing is continued, and there's our completed alignment. Don't forget, if you select the object based upon the constraints used to create this alignment, of course, it'll constrain the alignment based upon those constraints. And you'll get the grips that will apply those constraints so that you can't break them. If you want to remove constraints or change them, go to the Alignment Grid View editor, and then in the panorama window, you will notice the ability to actually change many of the constraints by simply clicking here, unlocking it, and then you can click the drop down here and change them as needed to. Don't forget as well, you can change any of the lengths or radii depending on how it was constrained and created in the first place. As with everything in Civil 3D, once you create an object, you can always change its properties afterwards. The Alignment Properties dialog box is where you change stationing, masking, how edits are displayed, and design criteria. Let's go ahead and look at Alignment Properties. To access the Alignment Properties, select your alignment, and navigate to the Modify panel and click Alignment Properties. You can change the style and type of alignment right here. You can change the station control. You can also add station equations if you have those in your design. You can also change the stationing, and it will update all the stationing automatically for the labels. If you have any areas in your design where you want to mask out the alignment, you can do so. Click the Add Masking Station right there. We'll go ahead and just select 2 locations for the station to station ranges and click Apply. And you'll notice that the alignment is completely masked through that area. And of course, you can remove it by simply clicking on the Remove Mask Station right there. The Point of Intersection tab is where you tell Civil 3D how you want your grip editing to be used when you're editing curves. Some additional editing toggles are available in the Constraint Editing. And then lastly, in the Design Criteria tab, this is where you define actual design criteria. So if you wanted to use some sort of AASHTO method, you could toggle this on here. You could then browse for the file to navigate to a criteria file. And then you would, of course, click on the AASHTO standard that you're interested in, and then apply it to the alignment. You can also check for tangencies between elements, which is a good idea, as well as the design check sets defined in the drawing. To add design speeds, you simply click on this plus sign, and you can just add the design speeds as you need to. Let's say we started at 40 miles an hour, then we can go into here and say at station 12 plus a pair, our speed limit will be 60 miles an hour, and click Apply. And it'll use this when doing super elevation calculations and all that good stuff. Civil 3D has a few ways that you can report on alignments. You can use the panorama window as well as a toolbox. First, let's go ahead and select our alignment and look at the panorama window way. We'll go ahead and click on Geometry Editor and then select the Alignment Grid View tool from the Alignment Layout tools. If you ever see any of these tabular type forms within the panorama window, you can copy these and paste them into Excel as tab delimited columns. Simply right-click, click on Copy All, and then inside Excel do a Control-V for paste. You can then use standard Excel formatting to remove columns, add columns, etc., and then save the file out if you need to. If you navigate to the toolbox, however, there's a Reports Manager located here. If you expand Alignment, there are some tools to report on alignments. There are 2 ways to report on alignment data. You can create something called a LAN-XML file that will then use a style sheet, which is an XSL file, to report on the data in the XML file. Then there are some additional tools that are actually programs where you execute a file. We'll go ahead and click on the Alignment Curve tool, as this one is going to export the alignment as an XML file. Now you don't want everything in the drawing, so clear all first, and then click on Pick from Drawing, and then select your alignment, right-click, and that will be the only object that gets saved to the XML file. Click OK, and then navigate to your dataset folder and call this one Bypass 1. Click Save. What Civil 3D will do is open up in your default browser the curve data saved here. You can then, of course, just select everything and copy and paste into Word or Excel, or you can right-click and do a Save As you need to. Let's go ahead and double-click the PI Station report. This tool here is actually an executable file that is being run. So this will actually run in the background, and when you click on Create Report, it then opens up in your default browser with the information that was supposed to be saved in the report. Civil 3D provides ways to create alignment labels and tables in your drawing. Let's discuss how to do this. Go ahead and select your alignment, and in the Labels and Tables panel, let's click on Add Labels. You could use the default commands right here, but when you do so, it will use the default label style defined in the command settings, and it will not allow you to choose a label style that you might want to choose from based upon the label you're selecting. So let's click on Add Alignment Labels instead. In the Add Labels dialog box, we have these different types of labels that we can place. Let's look at station offset first. We'll place station offset fixed point. We'll do a station offset and coordinate. Let's go ahead and choose the basic X one and click Add here. Then you're prompted to define a station offset. Of course, you could snap to existing objects if you need to define station offsets for those objects, or for now, we'll just click in space, and there's a station offset fixed point. Let's also now place a station offset label. Click Add, select the alignment, and let's place the station offset of this label. Let's see the difference between the station offset fixed point and the station offset label. So the station offset fixed point will actually stay where it is and update the new offset based upon your edit to the alignment, whereas the station offset label moves with the alignment. So you have the best of both worlds. Let's look at multiple segment labels. So multiple segment labels allow you to label the tangents and curves within your alignment. You can then choose the line label style, as you can see here. We'll click Add, select our alignment, and there are the labels labeling the alignment. What's great about the labels is that you can grip select them, and if you need to move them along the alignment, notice how they're masking. Now remember, you're not locked into what these label styles are displaying. Don't forget, if you go to the Settings tab, Alignment Category, you will be able to change any of the label styles defined in here. Let's look at alignment tables. We'll close here. Let's go ahead and select the alignment again, and we'll choose Add Tables. You can add line, curve, spiral, or segment tables. Let's click Add Segments. So it's going to use this table style right here, and you can select the alignment you want to do. You can split tables as well, but for now we'll toggle this off. Let's go ahead and click OK. Place the table, and it's linked to the alignment. So of course any changes made to the alignment will update the table. What happened to the alignment view is it actually made tags of those labels within the actual alignment, and it now is correlated to the table in here. So what Civil 3D actually did within the Settings tab was if we expand on the label styles and then expand line, you'll notice what it did by default is it creates a child style called .tag.1. And in that style, it tells a label to display a tag instead of the actual data, like the length, bearing, distance, etc. And so that's what's actually going on here. Now, if you ever need to renumber your tags, let's say they're out of sync or they're not in the correct order, select any one of them and click on the Renumber Tags tool, and then of course you can change the order in which it does things.